method. That's modulo. And we perform the same for y. Let's take a look at how this function works. For example, if we have the value 0.5 and we pass 1.0 as a value, we get 0.5 back. If we have 1.5, modulo 1 returns again 0.5 because it takes the remainder. If we had 10.6, the result is 0.6, and so on. So we are guaranteed to get a value between 0 when the value is 0.0 or 1.0 or 2.0, or a value between 0 and 1 if it's higher than 0, using this method. Now that we took care of the tiling of the UV coordinates, we can calculate the pixels using the getPixels function on the bitmap that we opened when we picked the object. Knowing that the bitmap is not undefined, we use the UV coordinates x multiplied by the bitmap width, and for the y we use the y component of the UV coordinates multiplied by the bitmap height. But we have to remember that the bitmap coordinates, just like the viewport coordinates, have their origin at the upper left corner, while the UV coordinates have the origin in the bottom left corner. So we have to flip the whole value by subtracting the result of this multiplication from the height. That means if we have a bitmap with size 256 and the calculation returned a value of 0, we're going to get the value of 256 at the end. And if the result of this multiplication was 256, the result would be 0. We also have to tell the getPixels function how many pixels to get. In this case, we get a single one. And then we make sure that the pixel that we took is actually valid. We say if the pixels, the first element, since getPixels always returns an array of pixels, even when we get a single one. If the first element, the one pixel that we wanted to check, is not undefined, then we can say pixel color, which is, as you probably remember, our color picker in the user interface. Its color property is equal to the first element from the pixels array. Otherwise, the pixel color is going to be set to red, which shows in the user interface whenever we see a pure red color, we couldn't get a valid pixel from the bitmap. This is the complete change to the code that we wanted to perform. We can make sure that all brackets are correctly closed in this case, and we can try to evaluate our new code. But before that, we'll go to the Views menu and activate all texture maps. We have some texture maps on these objects, and we're going to try to peek into the texels of the textures of these objects. If we pick the teapot now and move the mouse, we see that the color of the texel below the mouse pointer is being shown in the pixel color swatch. We can zoom a little bit closer and try to pick the red color from the boat, even the red color at the front of the boat. We can try to pick the plane and watch the colors of the sky, the snow on the mountains and the ground, or pick the sphere and watch the textile colors of the sunset sky appear in the color picker. This means that we used the barycentric coordinates in a very nice way to interpolate between the three UV coordinates in a face and figure out what UV coordinate the point of intersection actually has, and then ask the bitmap to return exactly that color to assign to the pixel color swatch.